Okay, on to if and only if. We've done if, we've done only if. Now when they're together, that's the biconditional double bar. Because you have if and only if, so it's going to be the double bar. Okay. Now for some reason, common mistake is students see this whole is students see only if alone and do the double arrow. That's wrong. A only if B is A arrow B. Okay, so only if by itself indicates consequent. That's why if, which indicates antecedent, and only if, which indicates consequent, together makes the double arrow, right? A if and only if B means A if B, which is B arrow A, but also A only if B. A has to have B, so A implies B. So each implies the other, which is A double bar B. Okay? If and only if, I'm calling it double bar, double arrow. If and only if together is the double bar. Okay? That says necessary and sufficient. So let's deal with necessary and sufficient as well, because you'll get that language in the exercises. Now there's a word order syntax thing that can throw you off here. So I'm going to give you the principle, and then there's a word order thing about whether we say X is necessary or a necessary condition is, whether it follows. But the key is you look at the sentence, again, you're thinking at truth condition level, you're translating and saying, what does it say is the necessary condition, consequent? What does it say is the sufficient condition, antecedent? Okay, so let's look at that. If and only if, together is the double bar. Only if by itself is going to be the arrow, and it indicates the consequent. Okay, let's look at necessary and sufficient. I'm putting up a lot. I was going to do this separately, but I've been putting up a lot of videos, so let's roll through this. Okay, necessary and sufficient. Okay, and you can separate them. Okay, necessary condition is necessary, etc. indicates consequent. Now, word order is going to be a little tricky, but we'll do that by working some examples. Indicates consequent. Okay? Right? In order to graduate, it is necessary for you to pass logic. Graduation implies passing logic. Okay? Passing logic is sufficient to graduate. Okay, sufficient condition indicates antecedent. That wording. To graduate, it's sufficient to pass logic. There might be other ways to graduate, but where you are with your credits, passing logic guarantees graduation, brings it along with it. Okay? Sufficient indicates necessary, indicates consequent, sufficient indicates antecedent. You can get language, and in fact, this is a philosophy application. When we're defining terms, sometimes we use if and only if language, right? Double bar. A shape is a square, if and only if, and then we use it for if and only if, right? Four sides and plane figure, and all sides are equal, and they're all right angles. Okay? So definition, we use if and only if, or we use necessary and sufficient conditions. Okay? You might say that virtue is both necessary and sufficient for happiness. Now that's a controversial claim, but I'm saying if you want to say, that means if you're virtuous, then you're happy, and if you're happy, that implies that you're virtuous. That would be what that claim is. So necessary and sufficient together, just like if and only if, is going to be the double bar. So necessary by itself, when you have a necessary condition specified, that indicates you're consequent, right? This says you have to pass logic to graduate. This says as long as you pass logic, you graduate, and there may be other ways to do it. Okay? Necessary and sufficient together, just like if and only if, right? So this would be a false claim, but you have life if and only if you have carbon. You have life. Carbon is necessary and sufficient for life. That's false. You can have carbon without having life. But if you said that, right, that would be the double bar. If you both have to pass logic, right, and then that guarantees you graduate, right, that would be you pass logic if and only if you graduate. Passing logic is necessary and sufficient for graduating. And this is going to be convert, right? This is going to be, they go together, right? Double bar order doesn't matter, right? Passing logic is necessary and sufficient for graduating. Graduating, necessary and sufficient condition for passing logic. Now that sounds strange, right? Because, well, you have to pass logic. That's what I'm telling you. They're logical relationships, right? If this is true, it follows that this is true. And if this is true, it follows that this is true. Both directions, okay? Necessary and sufficient, right, combines consequent indicator, antecedent indicator, right? If it says the same thing is both necessary and sufficient, if the same thing is both necessary and sufficient, passing logic is both necessary and sufficient for graduating, that's double bar. Sorry, double arrow. Okay, moving along here. I'm going to check the time here. 6 minutes. Okay. The last language terminology thing I want to do is unless. Unless. Yeah, I'll tack it on here. Unless. Okay. The simplest way to translate unless is with or, the wedge. Okay. Mets are winning in the ninth inning. The Mets will win unless the Dodgers score 6 runs in the ninth. Mets are winning by 5. Mets, and again, you can don't think you have to think of this as a prediction. You woke up, the Mets were up 5. The Mets won unless the Dodgers scored 6 in the ninth. This is true. Well, unless this is true. Okay, unless this is true. And note, look how the or works. That captures it right. Because when we say unless, we can be inclusive here, right? Maybe even if the Dodgers scored 6, the Mets got up in the bottom of the ninth and they won anyway. But the only way they lost, right, the only way this is not true is for this to be true. The simplest way to represent that is with the or. Now, what you're going to find is, right, not or equals arrow, and not arrow equals or, okay? So when we use the term unless, right, so this would be not unless. Not unless. When we use not unless, right, again, you can translate that using not and the or, right? We will not go to the movies unless you clean your room, okay? Which means, but that's the same as saying this. If we go to the movies, then you clean your room. So not or you can turn into the arrow, and not arrow you can turn into the or, right? Either the Mets won or the Dodgers scored 6 in the ninth. So if the Mets did not win, it follows that the Dodgers scored 6 in the ninth. So unless, not unless, actually has a relationship to the arrow. We'll work on this more in exercises. I know I'm doing this a little bit quick. The easiest, the most direct translation, whatever else is around it, if there's negations around it, you can translate negations, and the unless actually translates directly to the wedge. That'll be your simplest guide. Now, Hardegree puts something different in the exercises as the natural translation, but I'm telling you, equivalent here is that the unless translates to the or. Okay. Last thing, I'm making this video a little longer because we've covered some of the main stuff, and I want to get to working some exercises. Okay. Equivalent way of writing, of representing if-thens, and this comes into the, again, Hardegree's answers, so I wanted to note that. You can flip an arrow state, you can flip the antecedent consequent if you switch the negations, right? So this says if Ann is here, then Bob is here, right? I.e., right? So Bob is a necessary condition. Bob is here is a necessary condition, right? So if Bob is not here, then Ann is not, right? A implies B, so the falsity of this implies the falsity of this, okay? So if you can, so these are equivalent expressions, okay? If this doesn't help you, I'm going through this quick, but you can get an equivalent arrow statement by flipping antecedent and consequent and negating both. Okay? A implies B means if B is false, then A is false. If A is true, B is true. It's equivalent to if B is false, then A is false. It's not equivalent to if A is false, B is false, right? Remember our chart, right? Remember our chart. Our chart is true and true equals true. True and false equals false. Right? False, true equals true. False and false equals false. I keep doing that. False and false equals true. Right? If A is true, B has to be true. Right? Otherwise the whole statement's false. Right? So if B is false, right, A must also be false for the statement to be true. Okay. All right, I'm going to call this on our, it's kind of, these videos collectively go through a symbolization guide. I'm going to work some examples, and that will be your video guidance for Chapter 4.